One goal that we want to have is to be able to make a cheap night vision camera that we can equip all of the Marines with. And so it needs to be high efficiency and it needs to be low cost. The low cost comes from the fact that we're making it from silicon. And the high efficiency part is the part that we're working on now, and that's the hard part. What you really need to be capturing is a little bit of infrared light that's emitted by the starlight, which is outside, what our eyes can see. But if we can make a camera that can see in that range, then we can take advantage of this diffuse starlight that comes down in order for us to see objects. Now, doing that with silicon is not so easy because silicon doesn't respond at those wavelengths. So what we need to do is to come up with some creative way to do that. And we do that using a special process called ion implantation and pulse laser melting. Now then we take that material and we're going to make prototype devices out of it. So we go into the nanofab lab, we use typical silicon processing to make devices, and so this etches small structures and deposits metals. Ultimately what we get is a photodetector. The photodetector then we bring over to my laboratory and we do electrical and optical characterization on it to see how much response we get in the infrared. And then based on the results of the characterization, we can go back and refine the process. And ultimately what we want to do is to make a high efficiency photodetector out of this modified silicon for infrared detection and for night vision cameras. We want to show that, hey, this is a game changer. This can, result in, an entirely new set of devices that work in the infrared, and not just for night vision, but for a whole lot of other applications.